Hi, good evening, all of you. My name is B.SREENIVASULU, Department of Mechanical Engineering. Today I am going to the unit number 2, conduct flow. Last class, I can explain the pipes in connections, in series connection and parallel connections, and power transmitted to the nozzle. In this class, I can explain the Venturi meter, definition of the Venturi meter, and the derivation of the coefficient of discharge of the Venturi meter, and the derivation of the coefficient of discharge of the orifice meter. Okay, orifice meter, Venturi meter, flow meter. This meters also used in the measurement of flow. Flow measurement devices. Venturi meter is a one type of device, and orifice meter is a one type of device, and flow meter is a one type of device. These devices are used to the flow of water and the measurement of flow. Okay, next. This unit is conduct flow, unit number 2. In this unit is very easy and simple. I can divide it into 3 videos in this unit. I can explain already 2 videos. This is the third video, last video of the unit number 2. Next, Venturi meter. Venturi meter is a device. This is used to the measurement of flow. Okay, Venturi meter. Venturi meter is a device used for measuring the rate of flow of a fluid flowing through the pipe. Venturi meter is a device. It is used to the rate of flow of a fluid flowing through the pipe. It consists of 3 main parts. Okay, part 1 is the short converging part. Part 2 is the throat. Part 3 is the diverging part. Okay, Venturi meter is having a 3 parts. Part 1 is short converging. Okay, part 2 is throat value. Next is diverging part, convergent portion, throat value, and divergent portion. Okay, it is based on the principle of Bernoulli's equation. Okay, Bernoulli's equation derivation is I can explained in video number 1. Okay, Bernoulli's equation is I can explained already. P by rho g plus v square by 2g plus z1 equal to constant. That is the Bernoulli's equation. P by rho g v square by 2g plus z1 equal to constant. P by rho g is the pressure head, v square by 2g is the kinetic head, and z is the datum head. This equation is used in the Venturi meter derivation. Okay, the expression for the rate of flow of a Venturi meter. Consider a Venturi meter fitted into the horizontal pipe. Okay, fitted into the horizontal pipe through which a fluid is flowing as shown in figure. Okay, Venturi meter is connected to the parallel pipes and inclined pipes. In this derivation is used to the Venturi meter is connected in the parallel pipe or horizontal pipe. Okay, horizontal pipe means the inlet of the Venturi meter and outlet of the Venturi meter is datum head is constant. Okay, height of the inlet of the Venturi meter that equal to the end of the Venturi meter height is equal. That is called the horizontal connection of the Venturi meter. In this derivation, let small d1 is the diameter of the at the inlet at section 1, and P1 is the pressure at section 1, V1 is the velocity of fluid at section 1, and A is the area of at section 1, and section 1 and section 2. Section 1 is the converging portion, section 2 is throat portion, section 3 is diverging portion. Okay, in section 1, D1 and P1 and V1 A. Okay, D1 means diameter of the inlet pipe, and P1 means pressure at section 1, and V1 means velocity of fluid at section 1. A means area at section. Okay, that equal to pi by 4 into D1 square. Next, as shown in figure, this figure is a Venturi meter. Okay, portion number 1 and portion number 2 is connected with the manometers. Okay, two manometers. Okay, inlet pipe 1, throat value 2. Okay, 1 is the inlet pipe and 2 is the throat value. D1 is the diameter of the inlet pipe, and D2 is the diameter of the throat value. In this figure, the Venturi meter is connected in horizontal. Okay, the Venturi meter is connected in horizontal position. Okay, D2, P2, V2, A2 are corresponding values at section 2. D2 means diameter of the section 2, that is a throat 2. Next, P2 means pressure at section 2. V2 means velocity at section 2. Next, A2 means area at the section 2. Okay, next, applying the Bernoulli's equation at section 1 and section 2, we get the equation is P1 by rho g plus V1 square by 2g plus Z1 equal to P2 by rho g plus V2 square by 2g plus Z2. This is the Bernoulli's equation. P1 by rho g plus V1 square by 2g plus Z1 is the section 1 Bernoulli's equation. Next, P2 by rho g V2 square by 2g plus Z2 is the section 2 Bernoulli's equation. These two Bernoulli's equations are equal. Okay, two Bernoulli's equations are equating. Okay, as the pipe is horizontal. Okay, the Venturi meter is connected in horizontal pipe. Therefore, the datum head Z1 equal to Z2. The datum head Z1 equal to Z2. Okay. Therefore, the equation is written as P1 by rho g plus V1 square by 2g equal to P2 square by P2 by rho g plus V2 square by 2g. This is the Z1 equal to Z2. Therefore, write the above equation P1 by rho g plus V1 square by 2g equal to P2 by rho g plus V2 square by 2g. Z1 is cancelled both sides. So, in this equation is modified as P1 by rho g minus P2 by rho g equal to V2 square by 2g minus V1 square by 2g. Okay, P1 terms are one side and V1 terms are one side divided. Okay, in this equation P1 minus P2 by rho g equal to V2 square by 2g minus V1 square by 2g. In this equation P1 minus P2 by rho g is the difference of pressure heads. Difference of pressure heads. Okay, at section 1 and at section 2 is equal to H. Okay, pressure head H equal to P1 minus P2 by rho g. Okay, P1 minus P2 by rho g replacement with H value. Okay, the H is substituting the value of P1 minus P2 by rho g replacement. Okay, now the equation is H equal to V2 square by 2g minus V1 square by 2g. Now applying of continuity equation at section 1 and section 2. Continuity equation means A1 V1 equal to A2 V2. Okay, this is the continuity equation A1 V1 equal to A2 V2. In this equation, V1 is written as A2 V2 by A1. V1 equal to A2 V2 by A1. V1 value is substituted in the equation H equal to V2 square by 2G minus V1 square by 2G. Okay, therefore H equal to V2 square by 2G minus V1 equal to A2 V2 by A1 whole square divided by 2G. This equation is simplification V2 square by 2G into 1 minus A2 square by A1 square. Okay, V2 square by 2 is common term and also written as 1 minus A2 square by A1 square. Therefore, the equation is written as V2 square by 2G into A1 square minus A2 square by A1 square. Therefore, V2 square equal to 2GH into 2GH into A1 square by A1 square minus A2 square. Okay, now next V2 equal to root of 2GH into A1 square by A1 square minus A2 square, that equal to A1 by root of A1 square minus A2 square into root of 2GH. Therefore, Q equal to A2 V2, discharge Q equal to A2 V2. Okay, V2 value is calculated. That is A1 by root of A1 square minus A2 square into root of 2GH. Therefore, discharge Q equal to A2 V2. V2 value as substituted in the Q equal to A2 V2 equation. Okay, therefore Q equal to A2 into V2 value is A1 by root of A1 square minus A2 square into root of 2GH. Therefore, the equation is A1 A2 root of A1 square minus A2 square into root of 2GH. Okay, next, the equation is discharge under ideal conditions and it is called theoretical discharge. The actual discharge will be less than theoretical discharge. Therefore, Q actual equal to CD into A1 A2 divided by root of A1 square minus A2 square into root of 2GH, where CD is the coefficient of Venturi meter. Its value is less than 1. The coefficient of Venturi meter value is 0.98 to 0.99. Okay, that value is less than 1. Okay, the actual discharge equal to CD into A1 A2 by root of A1 square minus A2 square into root of 2GH. This derivation is very important in external examinations. A number of times are asked in previous question papers. Okay, next we can solve the small problem. A horizontal Venturi meter with inlet and throat diameters 30 centimeters and 15 centimeters respectively is used to measure the rate of flow of water. The, the reading of differential manometer connected to the inlet and throat is 20 centimeters of mercury. Determine the rate of flow. Take CD equal to 0.982. CD value is 0.982 to 0.99 is the constant value. Okay. First of all, to write down the given data. In this problem, given data is diameter of the inlet D1 equal to 30 centimeters, area at inlet A1 equal to pi by 4 into D1 square, that equal to D1 value as substituted in the A1 equal to pi by 4 into D1 square. Okay, pi by 4 into 30 square, that equal to 706.85 centimeter square. Next, diameter at a throat value. Okay, D2 equal to 15 centimeters. So D2 equal to 15 centimeters is the throat value. Next, A2 equal to 5 by 4 into D2 square. Okay, 5 by 4 into D2 means 15. Okay, 176.7 centimeter square. CD equal to 0.98. Okay, already given in the problem. Coefficient of discharge. CD equal to 0.98. Reading of differential manometer X equal to 20 centimeter of mercury. Okay, reading of differential manometer X equal to 20 centimeter of mercury. Okay, is given in the problem. Difference of pressure head is given by H equal to X into SH by S naught minus 1. Okay, H equal to X into SH by S naught minus 1. SH equal to specific gravity of mercury, that equal to 13.6. S naught equal to specific gravity of water, that equal to 1. Mercury specific gravity equal to 13.6. This is the constant value. Okay, water specific gravity equal to 1. Therefore, H equal to 20 into 13.6 by 1 minus 1, that equal to 20 into 12.6 centimeters. So that equal to 252.0 centimeter of water. Okay, therefore H value is 252.0 centimeter of water. The discharge through Venturi meter is given. The discharge through Venturi meter is given by, okay na, the equation discharge to the Venturi meter Q equal to CD into A1 A2 root of A1 square minus A2 square into root of 2GH. Okay, CD value as already given in the problem 0.982 into A1 value is already calculated in the problem 706.85, and also A2 value is also calculated, that equal to 176.7 divided by A1 square minus A2 square into root of 2GH. 2 into G is the 9.81. This is the constant value, and H is the already calculated, H equal to X into SH minus S naught minus 1. That value is 252. Okay, all values are substituted in the equation discharge Q equal to CD into A1 A2 root of 2GH into A1 A2 divided by root of A1 square minus A2 square into root of 2GH. Okay, next the values are calculated. Okay, therefore the discharge value is 125,756 centimeter cube per second. Okay, discharge units are meter cube per second, or mm cube per second, or centimeter cube per second. Okay, in this problem, the values are given in the centimeters. Also, the discharge units are centimeter cube per second. Therefore, the centimeter cube per second is converted into the liters per second, that equal to 125,756 divided by 1000, that equal to converted into the liter per second, 125.756 liter per second. Okay, next, this is the problem number 2. Okay, an oil of specific gravity 0.8 is following through a Venturi meter having inlet diameter and throat diameter 10 centimeters. The oil of mercury differential manometer has shown as a recording of 25 centimeters. Okay, 25 centimeters. Calculate the discharge of oil through the horizontal Venturi meter. Take CD equal to 0.98. This is the another problem. Okay, the specific gravity of oil is given in the problem, S0 equal to 0.8. Okay, the specific gravity of the mercury given mercury is 13.6. Okay, next, recording of reading of differential manometer x equal to 25 centimeters. Therefore, the difference of pressure head h equal to x into sh by s0 minus 1. sh by s0 minus 1. Okay, this is the equation. In this equation, x value and sh value and s0 value is substituted. Okay, therefore the equation is 25 into 13.6 divided by 0.8 minus 1 centimeter of oil, that equal to 25 into 17 minus 1, that equal to 400 centimeter of oil. Okay, 400 centimeter of oil. H value is 400 centimeter of oil. Dia of inlet D1 equal to 20 centimeters. Dia of inlet D1 equal to 20 centimeters. Okay, next, A1 equal to pi by 4 into D1 square. A1 equal to pi by 4 into D1 square. A1 equal to pi by 4 into D1 square. D1 means 20. Okay, 20 value is substituted in the A1 equation, pi by 4 into 20 square, that equal to 314.16 centimeter square. Therefore, D2 is the 10 centimeters. This is the given in the problem. Okay, therefore A2 equal to pi by 4 into dt square. Okay, that value is 78.54 centimeter square. CD is the 0.98. CD value is given in the problem, 0.98. Okay, next, the Q value is, the discharge Q value is Q equal to CD into A1 A2 divided by root of A1 square minus A2 square into root of 2GH. Okay, in this equation, CD value and A1 value and A2 value and G value and H value, all values are substituted in the discharge equation. Therefore, the equation is written as 0.98 into 314.16 into 78.54 divided by root of 314.16 whole square minus 78.54 whole square into root of 2 into 9.81 into 400. Okay, 9.81 meter per second. Okay, the G value, this is converted into the centimeters. Therefore, the calculated value is 70465 centimeter cube per second. This is converted into the liter per second. Okay, this value is converted into the liter per second. Okay, that is 70.465 liter per second. Next, this is the another problem. A 30 centimeter and 15 centimeter Venturi meter is inserted in a vertical pipe carrying water flowing in the upward direction. A differential mercury manometer connected to the inlet and throat gives a reading of 20 centimeters. Find the discharge. Take CD equal to 0.98. Okay, dia at inlet. Dia at inlet G1 equal to 30 centimeters. Okay, diameter of the inlet pipe equal to 30 centimeters, and to calculate the A1 equal to pi by 4 into D1 square. D1 equal to 30. Okay, we can also find the A1 equal to 706.85 centimeters square. Okay, dia at throat D2 equal to 15 centimeters. Therefore, A2 equal to pi by 4 into 15 square, that equal to 176.7 centimeters square. Okay, next, H equal to x into sh minus s0 minus 1, that equal to 20 into 13.6 by 1 minus 1, that equal to 20 into 12.6, that equal to 252.0 centimeter of water. Water. Okay. Next, CD value is 0.98. Okay. Therefore, discharge Q equal to CD into A1 A2 root of A1 square minus A2 square into root of 2GH. Therefore, the values are calculated. The discharge value is 125.756 liter per second. Okay. Next, orifice meter. It is a device used for measuring the rate of flow of a fluid through a pipe. It is a safer device as compared to the Venturi meter. It also works on the same principle as that of Venturi meter. It consists of a flat circular plate which has a circular sharp edged hole. It is called orifice, which is connecting with pipe. The orifice diameter is kept generally 0.5 times of the diameter of the pipe. Through it may vary from 0.4 to 0.8 times of the pipe diameter. The orifice diameter is 0.8 to 0.4 to 0.8 times of the pipe diameters. Okay. A differential manometer is connected at section 1, which is at a distance of about 1.5 to 2.0 times the pipe diameter. Upstream from the orifice plate and at section 2, which is at a distance of about half the diameter of the orifice on the downstream side from the orifice plate. Okay, next, this is the orifice meter. Okay, differential manometer is connected to the orifice meter. Okay, the direction of flow left side. Okay, pipe 1 and pipe 2 is a orifice. Orifice means the small narrow section. The small narrow section. Okay, this diameter is the half of the pipe diameter or 0.4 to 0.8 times of the pipe diameters. Okay, let P1 is the pressure at section 1. V1 is the velocity at section 1. A1 is the area of pipe at section 1. Okay, in this orifice meter, P1 pressure at section 1, V1 velocity at section 1, A1 area of pipe at section 1. Okay, direction of flow, the water is flowing into the pipe. Okay, next, the water flow is reduced in the orifice section. Next, the water is coming out from the pipe. Both sides pipe diameter is same and the orifice diameter is different. Okay, in this orifice meter, two different diameters and two different areas and two different velocities. Okay, in section 1, pipe diameters, pipe areas and pipe velocities. Next, P2, V2, A2 are corresponding values at section 2. Okay, this is the orifice section. Okay, P2, V2, A2 are the pipe 2 section 2. This is the orifice. Okay, P2 is the pressure at section 2, V2 is the velocity at section 2, A2 is the area of the at section 2. In this orifice meter, the Bernoulli equation is applying section 1 and section 2. The Bernoulli equation is P1 by rho g plus V1 square by 2g plus Z1 equal to P2 by rho g plus V2 square by 2g plus Z2. Okay, P1, V1, Z1 is the section 1. P2, V2, Z2 is the section 2. In this equation, Z1 and Z2 are different. Okay, already calculated in the discharge equation of the Venturi meter, Z1 and Z2 values are same. Okay, in this equation are Z1 and Z2 is different. Okay, next you can P1 by rho g plus Z1. P1 by rho g plus Z1 minus P2 by rho g plus Z2 equal to V2 square by 2g minus V1 square by 2g. Okay, therefore P1 by rho g plus Z1 minus P2 by rho g plus Z2 equal to differentially have the H. Before we can calculate the Venturi meter derivation, P1 minus P2 by rho g equal to H. In this equation, Z is added. Okay, in this equation, Z is added. P1 by rho g plus Z1 minus P1 by rho g, P2 by rho g plus Z2 equal to H. Okay, in this total section, replace with H. Okay, therefore H equal to V2 square by 2g minus V1 square by 2g. Okay, now therefore in this equation 2gh equal to V2 square minus V1 square. Now section 2, the vena contacta and A2 represents the area at the vena contacta if A0 is the area of orifice. Therefore CC equal to A2 by A0. Okay, where Cc is the coefficient of contraction. The coefficient of contraction equal to A2 by A0. Okay, therefore A2 equal to A0 into Cc. Before Cc equal to A2 by A0. In this equation, A2 is A0 into Cc. By continuity equation, we have A1 V1 equal to A2 V2. In this equation, V1 equal to A2 by A1 into V2. Okay, that equal to A0 minus Cc by A1 into V2. Because of the A2 value is A0 Cc. Okay, therefore, the value V2 equal to root of 2gh plus A0 square Cc square V2 square divided by A1 square. Okay, therefore V2 square equal to 2gh plus A0 by A1 whole square Cc square V2 square. Therefore V2 square into 1 minus A0 by A1 square Cc square that equal to 2gh. Therefore V2 equal to root of 2gh by root of 1 minus A0 by A1 whole square into Cc square. Therefore A2 equal to A0 into Cc. The discharge Q equal to A2 V2, A2 A0 Cc. Okay, that equal to A0 Cc root of 2gh by 1 minus A0 by A1 whole square into Cc square. Okay, the equation is CD equal to Cc into root of 1 minus A0 by A1 whole square divided by root of 1 minus A0 by A1 whole square into Tc square. Therefore, the equation Cc equal to Cd into root of 1 minus A0 by A1 whole square into Cc square divided by root of 1 minus A0 by A1 whole square. Okay. Now, substituting the Cc value in equation 4, we get Q equal to A0 Cd into 1 minus A0 by A1 whole square into Cc square divided by 1 minus A0 by A1 whole square into root of 2gh by root of 1 minus A0 by A1 square into Cc square. Therefore, the equation is written as Cd into A0 root of 2gh by 1 minus A0 by A1 whole square. Therefore, the equation is written as Cd A0 A1 root of 2gh by root of A1 square minus A2 square. This is the discharge value of the Venturi orifice meter. Okay, coefficient of discharge of the Venturi meter and coefficient of discharge of the orifice meter. Okay, in this video, I can explain the to calculate the coefficient of discharge of the Venturi meter and to solve the small problems on the Venturi meter and to derive the equation of the coefficient of discharge of the orifice meter.